Okay, let's start. A couple of words in English about the tutorial. Today's tutorial will be devoted to named entity recognition using DeepPavlov library. Maybe you have already heard about this task, but for those who don't, I will remind you. The named entity recognition is the task of extraction of named entities, which are names such as Young Goodfellow or John Nash, maybe organizations like Google or MIT, locations like Russia, Moscow, etc. Time expressions like yesterday, this year, or maybe tomorrow. Quantities like 10, dozens, or something like this. Monetary values like rubles, $10,000, or anything like money. And how we pose the task. At this slide, you can see an example with named entity markup. And the task of named entity recognition can be treated as following. For each token in the given sequence of tokens, provide a tag from the predefined set of tags. In this case, we have two types of tags. It's persons and locations. You can see an O tag, which stands for out of tag. So there is the no tag is also a tag. You can also see prefixes like B and I. We introduced those prefixes to resolve the issue of consecutive entities. For example, here you can see two consecutive entities which we want to separate out. And for this purpose, we use two types of prefixes, beginning and inside. Okay. What we're going to use to solve this task? B stands for beginning. If you have, for example, person whose name is Zdislav Beksinski, it's a single person, and you want to extract this person as a single chunk of data. You want to provide this as a whole name, and for this purpose, you use beginning and inside. And then if you have another person just after this person, you can resolve them. If you have a number of names standing one right after each other, you can resolve them to extract different persons from the text. So the prefixes is just about resolving consecutive entities. B is the first token of the Oh, I see. It would be two separate B tags. So if you have this case, you cannot resolve it with this type of markup, but it's used. But we say that it's okay. We're gonna solve it in this way, just using B tags for each of these person, despite it's a single person. But it's okay. It's another task. You can solve it, for example, using a semantic parser or syntactic parser. Yeah. Yeah, but it would be two separate B tokens.
How would it look like if the name contains with middle name?
Oh, it would be 3 consecutive tokens and 3 consecutive tags, which would be BII person. BII. Okay. Okay. The network we're gonna use to solve this task, it's a simple baseline, but it's a good starting point. It would be a convolutional neural network which uses an embeddings of the words, which will be trained on the go. You will initialize those embeddings with random values and train those embeddings right with the convolutional neural network. And you have, for each token, you will have an output, which will be a tag. in our case, it can be something like I person or B person or O tag. For doing this, we need a couple of things that are almost the same for every task in natural language processing. Namely, first of all, to train this network, you have to download the data set and parse it into the right format. We will use already existing dataset reader. It will read the dataset into pairs of sequences of tokens and sequences of tags. So you will use it, and you just got the result. The second thing is when we have downloaded this dataset, we would like to generate batches from them. Because almost every neural network is trained with batches, and we will use also a batch generator from the library to sample from the dataset and generate batches. But you cannot pass the text into the network directly, so we need a third thing. It's a vocabulary. It will perform a conversion from the indices to tokens and from tokens to indices. You can get indices from every input sentence, put them into the batch of indices, and then embed those indices and put all the stuff in the network. You also have a similar vocabulary on the top to produce one-hot representations for our tags. And actually, it's all will be reused from the library. You do not need to write your own code, so you will use implementations that exist in the library. Actually, they are quite the same for almost every task. Those three parts are almost identical for many of NLP tasks. So it's boilerplate code. You can reuse it many times. So I suggest you to use those methods for your implementations of the network. And what you're gonna do in this tutorial, you're gonna build the heart of the whole system. It's a neural network along with embeddings. You need to generate embeddings. Firstly, you need to initialize random matrix of embeddings and put these matrices into embedding lookup. The second thing, you need to build a convolutional neural network. Don't be scared. You will have some examples of convolutional layers. Here you need to build a multi-layer convolutional neural network. And the last part, you need to produce a loss function from the predictions which we get on the top of the network. We use cross entropy with a little features like it is mask cross entropy. You also will get the details in the notebook you will be provided. And actually, that's all. You need to build a simple convolutional neural network that produce predictions for each token, which tag it should be. Either it's person, either it's maybe it's organization or location. Couple of words about the data set. We use ConLL 2003 dataset. It's a news dataset with named entity markup. There are three types of entities, namely persons, organizations, and locations. It's very common types of entities. So, and it's kind of benchmark data set on which you can test your architectures and get some results. Maybe you can beat state of the art. It's like a competition data set. So that's almost all. I think you will get all details from the notebooks because they're well annotated, and there will be a lot of examples preceding these tasks. So that's all. I hope you start just after we got there. So thank you. Any questions? Right back prop, you will use an existing optimizer such as Adam, and you just use the results of these optimizer. Thank you.